Welcome, everybody. This is a 24 hours of PaaS session. This session will be presented by James Serra on relational database versus non-relational database versus Hadoop. And this session will be this session is provided by the 24 hours, and all the sessions will be recorded and will be available at the earliest around this week or maybe around next week. So, and if you have any technical questions, we will that can be put in the right. There is a right to a window pane where you can have the next slide, please. Sorry. So for any technical assistance, if you have any questions or any questions, if you're not able to hear, please type it in the question pane, and we'll try to answer it as soon as possible. And if you have any, if you need to zoom in the presentation, you can do it on the Zoom button. At the end, after the presentation, there will be a short survey. We'd appreciate if everybody presents and everybody is able to fill out that evaluation. It will be a great help, and it will help us to be a more, give us more feedback and present it more better the next time. And this session is definitely without the sponsors. Our main sponsors, the Microsoft Quotework, Amazon Web Service, and Redgate. Without them, this wouldn't be possible, and all the sessions are brought free of cost to everybody, and we really also thank the support sponsors, that is Hadoop, SQL Sentry, and ScanDisk also. So without them, we wouldn't be possible to present all the session free of cost in 24 hours in a day. And without further ado, and one more thing is left, like if you since this PaaS is a non-profit organization, and there are different sessions and there are virtual chapters available, so you can go to www.sqlpaas.org. You'll be able to find a local chapter within your locations, or any different locations you can join the different virtual chapters, which has a lot of information, knowledge, and basically all the trainings and data and everything, all the webinars is available, so you can take advantage of that. So be sure to, and its membership is free of charge, so you don't have to pay anything. So, and this presented by James Serra, and he's been solution architect for Microsoft and has over almost 30 years of experience in business intelligence, and he has previously worked as a independent consultant and different areas, and he has started since COBOL, so he knows what he's doing, and he's also authored a book, Reporting with SQL Server 2012. So without further ado, I would let James take on from here. James.
Great. Thanks for the introduction, and welcome everybody to relational databases, your SQL servers versus non-relational databases, mainly NoSQL and Hadoop. This presentation, I'm going to start out by talking a little bit about the definition and differences of those three technologies, and we'll talk about acid versus base, the categories of NoSQL, some of the use cases, the CAP theorem, a little bit about the cloud. We'll try to categorize how all these products fit together. We'll talk a little bit about polyglot persistence, and then have some samples at the end. Please type your questions in the message window, and I'll answer them at the very end. And if I don't have enough time to answer all of them, I'll follow up with an email with all the answers. And this presentation came about because I was a DBA for many years, dealing with SQL Server and RDBMS, and maybe 5 or 6 years ago, I started seeing people talk about Hadoop, and then shortly after that, NoSQL, and I was very confused. Well, what use cases would I want to use these? Do they replace SQL Server? Do they supplement it all? I couldn't quite understand it all. And as I gathered the knowledge about that, about how they all worked and the use cases, I put this deck together over the past year, and finding a lot of interest in this because there's a lot of confusion on all these various technologies. Our jobs are hard enough it is understanding SQL Server and all the new features in here. Now we need to understand how all these other products fit into in a case where I'm needing to store data in a database. And so my goal at this presentation is to educate you enough about all these various technologies and tools so you can look like a hero in your organization. When you hear a particular use case and this discussion goes on, you can chime in on what you know about these various technologies and hopefully take your company down the right path and you choosing the right tool. So quickly to talk about relational RDBMSs or SQL databases, we know them as SQL Server, Oracle, MySQL and such, and they're mostly used in large enterprise scenarios. With the exception of MySQL, you'll see that when people talk about the LAMP stack, the Linux, Apache, MySQL, and Python, that's the one exception of relational solutions that I see out there. I don't see it too much in my world, and I go around to a lot of larger companies, enterprise companies, and talk technology with them about the various Microsoft products as well as about Hadoop and NoSQL. And keep in mind there's also a sort of another category of relational databases called the analytical RDBMSs. These are old lap, you may hear the term MPP, multi-parallel processing. These are the APS, the Teradata, and the teaser when you have really large data warehouses and you need to process queries and you may have performance issues with a regular SQL server, so people will turn to those kind of solutions. Now when we get into non-relational databases or the NoSQL, we're talking about the popular products you may have heard of like MongoDB, DocumentDB, Cassandra, HBase, and such. And there's 4 categories that we'll talk more about: key value stores, wide column stores, document stores, and graph stores. Those are the 4 main categories you see all the NoSQL solutions grouped into. Then we got Hadoop. Now Hadoop is a file system, not a database solution in here. It's basically made up of the file system called HDFS and Yarn and MapReduce. And over the years it started with just MapReduce and then they introduced Yarn and they got Storm and Spark and now Flink and it goes on and on. But the basics of Hadoop is those 3 technologies underlying it all. This is how it got started, and I do this to put it in some kind of context. We may have start out with RDBMS. I need to index, say, a few thousand documents. Well, in SQL, that's no problem. We have a feature called full text search. I can do that, and I can get some very good performance out of that. Well, what happens if someone comes along and says, I want to index a few million web pages? And this happened many years ago with the Googles and the Yahoos in there. And a SQL Server or Oracle, they're not going to be able to handle millions, if not billions, of web pages in there. This is where Hadoop came in. It was the solution to index millions and billions of pages in there, and it did it in the scalable architecture that we'll talk about. Another situation came along. I have an RDBMS, it's like a SQL Server, and I need to handle a few thousand transactions a day. No problem. I can use SQL Server for that, maybe even millions of transactions a day. But what happens, and I can upgrade hardware, and it's over the years it keeps doubling and tripling in the performance in there, so I can keep progressing up to a certain ceiling. What happens if I create a website and I'm having millions of transactions a day? So instead of having this internal application that's used by maybe a few thousand people in my company, I put a web out there or a phone app, and I'm getting millions and millions of transactions, maybe even per hour or even per minute in there. Well, no way a SQL Server can handle that. That's where NoSQL came into play. Keep in mind, you hear a lot about Hadoop, you hear about NoSQL, but 89% of the market share by Gartner is use RDBMSs. So we hear a lot of people talking about it, but we don't see it taking over SQL Server or other RDBMSs. We don't see it being used for all new products. It has a certain use case for these NoSQL and Hadoop we'll talk about, but it's by no means going to replace everything. The SQL Server is going to be around forever. So quickly, when we talk about relational, we also know that we talk about structured data. We talk about ACID when we mean to have transactional consistency. We have joins. We have data integrity built in, a large ecosystem of third-party products for it. We can define relationships with constraints. we can have just tons of indexing on there. We can have full user support, and then we can have solutions that could be OLTP, transactional, or OLAP for data warehousing and such. What are the problems we have with relational? Well, we all probably know that we can't scale out horizontally, only scale up. So again, we can hit a hardware limit of what we can support. If we want to scale out vertically, there are solutions like sharding, but those are not trivial. They generally require some additional coding and monitoring and they're not automated solutions on that. The good thing about normalizing data is it makes it easy to understand the data, but it also results in a lot of joins, and this could affect speed. Some of the solutions could join dozens of tables in there, and that's a problem when you're dealing with some sophisticated queries in there. So we've all run into that as DBAs in there. It has problems with semi-structured data. They're taking approaches with SQL Server. We can support XML and now JSON and SQL Server 2016, but it's kind of limited in what it can do, and it's not going to give you a lot of speed you need. And then it's schema on write, meaning I have to define a schema before I store data in there, as opposed to a schema on read, which means I can just throw data into a solution and then only define the structure when I pull it out. So there's a lot of more upfront work that has to be done when I'm creating a relational model. And then the cost. Some of these NoSQLs or Hadoop solutions are free, and with SQL there's a licensing fee, or with any other competitors to SQL. Now let's talk about NoSQL. It's a bad name. It should have been called instead of NoSQL, I wish it would have been called non-relational, because there is SQL as part of it. So that's something to keep in mind. It works with semi-structured data. So when we look at JSON documents, XML documents, that's what most of NoSQL solutions deal with. It can scale out horizontally, so I can add more servers into the mix, and it can give me this parallel query performance. It can give me replication of the data, so I have high availability in, and I can make clusters anywhere from a couple of clusters to thousands of clusters in there. It can support high concurrency, a lot of random reads and writes. So if we need to have those web applications I mentioned before, or phone apps that are going to have thousands, if not millions of users, that's what NoSQL can do. It can work on massive data stores. It has that schema on read, which means it allows you to be schema free, and that I can not only store data without having to define it up front, that data, the formats can change and not break my code, as what will happen in a relational system. It has high availability built in. As mentioned, the cost can be cheap. Now that's all relative, because generally you're going to pay costs in other areas like support, but the licensing on that can be a great reduction in what you have to shell out. It makes it easier to develop solutions if all your data is sitting in a document and not spread out among tables. If you're building a solution, a web app, and you have to code in relational, then there's what they call impedance mismatch, which I may be dealing with an order, but then I got to break it up to store it in the database, where if I have a JSON document, I don't need to do that. So it makes it quicker to build solutions in there. And the availability, you can have finer control of how that works, and then you can have a lot of speed in there because you're not having to join tables. All the documents, all the fields in a table, in essence, are stored in one document. We'll talk more about that. There are a lot of cons to go over these quickly. It doesn't support ACID. It uses base, and we'll talk about that. It has limited support for joins. Some don't support joins at all. The data is denormalized. You can say, well, it's not a big problem because storage is cheap, but you got to keep that in mind. It doesn't have built-in data integrity. You must do it in the code. It doesn't have enforcement relations. And think about it, that's because there's no schema. It lands as it is in there, and so there's no upfront work. But on the cons of that is there's no built-in relationship monitoring in there. They generally have limited indexing. It doesn't usually support all the SQL. It has limited transactional support, and we'll talk about use cases when that may be okay or not. It generally doesn't support mass updates. It uses more space because of that denormalized. And you could have difficulty. One of the cons about having schema less is that's great, but it could make it difficult to track changes that have been made over the schema over time and such. And I should point out, people can argue with me, vendors can argue with me about all these cons, and some of the NoSQL solutions have all these cons, some don't. Some have taken steps to remove some of these cons in there, but you can go on an argument day in and day out, but this is generally what I see when you look at all the various NoSQL solutions in there. And the lines are getting very blurred. When you look at these products, some say they can be all the solution to everything in there, but just take all that with a grain of salt, because there's going to be trade-offs. Now let's talk about Hadoop. It's a file system in there. It's not a database, so just keep that in mind. It doesn't have any inherent structure, meaning this is one of the pros in that I can land data in Hadoop in any format. It could be a CSV file, it could be a JSON or XML file, but it could also be a video file or audio file. I can throw anything I want in a Hadoop solution in there, where in the NoSQL you have to, if you have a CSV file, you have to convert it to JSON. It's great for batch processing, large files, huge amount of writes, huge sequential access. That's what Hadoop really shines in there, because it's scaling all this out among huge clusters in there. So we're seeing solutions where clients need to run reports or any sort of analytics at the end of the day. They don't care if it takes a few hours. Hadoop can be ideal for that. There's a trade-off in that the technology sacrifices speed by the way it's built in there. So one of the cons you'll see in Hadoop is it's not good for, you wouldn't want to attach this to a dashboard because you're not going to get that millisecond response time you need in there. It's not good if you have millions of users in there. It doesn't do well for high concurrency in there. It's not an OLTP solution. You're not going to use Hadoop to build some order tracking system in there or CRM or EDP systems in there. It lacks, these are the two things we see that people run into when they use Hadoop solution. It doesn't have indexing built in, and it doesn't have metadata with it. Now there are third-party solutions that can give you indexing on Hadoop, and that can give you the metadata layer that you need, but that's not built in there, so it takes some extra effort to create that. And it doesn't have things like query optimizers or memory management, so that's where the sacrificing and the speed comes in there. And all those content I mentioned about non-relational apply to the Hadoop solutions, such as the ACID support and the data integrity and things like that. And then security limitations. Hadoop is not, doesn't have near the amount of security solutions that a SQL Server will have, where you have all row security and TDE and all these new features that have come out with data masking and all that. All that is not built into Hadoop. Now again, you can probably find third-party solutions that you can use, but now that's adding complexity to the solution you build. When we talk about ACID versus base, well, most of us as DBA should know what ACID is, and that's the consistency and autonomy and isolation durability of a transaction. So I can have a begin transaction, do a bunch of statements, and then an end commit, end transaction, and it'll commit it all or nothing approach in there, which you need to have for various use cases like financial applications or generally CRM or EDP. They need all that in there. Where the base is the basically available soft state, and it's eventually consistent. And that's the key, is eventually consistent. And that's where you'll see the big difference between the two is because you are replicating the data, I can have it over many different clusters, and once I update it in one cluster, it may take a while to replicate the other clusters. Think of it as sort of like availability groups that could be synchronized or not synchronized in there, and you're going to sacrifice something. If you say you want it synchronized, well, now it's going to wait till everything is copied and then before it's committed, and that can really sacrifice in speed. And so that's the balance you have. But that could be great for a lot of cases. I don't maybe need consistency if I'm running a report that's counting the number of users on web pages. If it's accurate or I get like a dirty read, it's not a big deal in there. But, you know, financial ATM withdrawals, dealing with checking account balances, all that stuff, then you need it. So that's where you got to look up front of the use cases for the solution you're building and if you need that ACID or not. We'll talk about the use cases of NoSQL. So we all know about relational stores. The data is stored in tables. We got the schemas, everything I mentioned before. And if we look at an example, I may have, say, a dog and I'm tracking, and I keep note of when it barks and then the comments that are made when the dog barks in this. In this case, we'd have various relational tables. We should know this pretty well. Now let's go to a key value stores. This is one of the NoSQL solutions. You have a key and a value. It's great for very simplistic solutions in here. In this example, I can have a key, which could be a dog, sort of like an identity, and then the value could be multiple values in there. So I can have a name value of Stella and a mood value of happy and so on. So it's very good, and we'll bring up use cases, but think of tracking stocks or a leaderboard and things like that. The wide column store is very similar to keys, but we group things in columns. You may become familiar with columnar in SQL Server. It's the same concept in there, where we can have a primary key, we can have multiple secondary keys, but the primary keys have multiple values, but they're broken in the columns. And so we have a column family. In this case, we get the same ID, but we have a column family of dog, and then we can have a title. We can timestamp it, so it shows how changes of time, and then we have the values in here. And this allows you to get a lot of more performance in there, because with a column, we can store it in such a way that we have in memory, we compress it all, and it can be much faster in there. So we see, and I'll talk about Cassandra as one of the solutions in there. This could be great if you really have high performance needs for your solution and high concurrency. Third one is document stores. I thought, well, what are you talking about, like Word documents? Well, no, it's not Word documents. It's actually a JSON document. This allows you to put all your data in one file that's a JSON file. In this example, I have the key value again, but I put it in the document. It's just JSON. You have identifier and a value in here. And to the right, you can see I can even take it to where I can embed comments in here, and I can have none or one or many of them. And so this is where you see the schema can change. And this is something that would be extremely difficult to support in a SQL Server solution here, but it works quite well in when you're using a document store. And then there's graph store. Graphs are very different than the other three in here. This is great for defining relationships between pieces of data. So if I look at my example, even something like that, I can define relationships. I can say a dog's mood, dog and happy are related by the mood, a dog and the Stella are related by the name. So you can think about, well, this would be great for something like Facebook or LinkedIn, where you need to define those relationships. And so there's actually a ton of use cases for graph stores, and we'll talk about some of those in a minute. So here's the use cases at a high level for those four various categories. We have the key value stores, Redis as being the typical solution. You think for cache or queues, data that's changing a lot, such as a shopping cart, session data in your web, a leaderboard, stock prices. This gives you the fastest performance. Next step up is the wide column stores. Cassandra is the most popular in this. This is great for querying of a lot of data randomly. When you have huge number of writes, if you're doing sensors, IoT kinds of things, real-time data analytics, things in the banking industry, we see this Cassandra used a lot. Any kind of time series analytics, Cassandra is a great use case for that. Document stores, the most popular of that is MongoDB. This is great for when you need flexible schemas, when you need really good performance and a lot of data, when you have dynamic queries. Think of order data, customer data, log data. This is another one, user-generated content like chat sessions, tweets, blog posts, comments. Think of how difficult those are to put in SQL Server to build a fast solution with things like chat sessions. Work perfect in document stores, and you can really develop quickly with a MongoDB solution in there. And then the graph databases, Neo4j is the most popular. Great for social networking, master data management. Think of all the real-time recommendations you have on Amazon, or fraud detection, or graph-based search, web browsing, gene sequencing. All those kind of things are really great because they work through relationships, and that's where graph databases shine. This slide I like because it gives you some idea of the number of transactions per second that each of these, the various solutions will support in there. So you want to keep that in mind. If somebody says I need 5,000 transactions per second, you can actually get that in relational databases. It may take an appliance or some really good tuning for your great DBAs out there and indexing and fast storage, fast memory, etc. in there. But when we start getting into tens of thousands, hundreds of thousands, 500,000, we're going to start looking at these other solutions. And this gives you a ballpark of which solutions you want to look at and cluster size and things like that. So again, I'm throwing out a lot of high-level understanding of these technologies so you can kind of focus in on the right area when you're looking to build a new solution. If we look at it, when we balance this against size and complexity, as we get more to the right, then we start getting to the document DB and the graphics DB. They're a little more complex in the key value and the column in there. But I always like to point out is, I'm talking about all these great technologies, but most of what we see, that 89%, is in that typical RDBMS in there. And I've seen people try to go and use NoSQL for very small data sets, and it just doesn't make a lot of sense. Yeah, there's exceptions if you have no experience in SQL Server and you're starting a new company, and yeah, sure, okay, you can go with a NoSQL solution in there. Most of the clients I deal with, and probably most people on this call, are in an organization that's already got a heavy investment in NoSQL, so or SQL Server or Oracle and such. So it's not going to be easy to transition over in there. So you want to keep a lot of those in what your the solutions you're currently, the technology you're currently using, like SQL Server in there. But as you get more data volumes and we start talking about the big data and IoT, then you may want to start keeping in mind, you may want to look into some NoSQL solution in there, especially when you're dealing with semi-structured data, high availability schemaless data. That can make it more of a use case for using a NoSQL solution. Just to confuse you more, there is a solution called NewSQL that I started hearing about a year ago. And this is, it sort of leaves off where regular SQL Server doesn't do well, and that's scaling the data. And instead of having to jump to a NoSQL solution, this filled the gap between the NoSQL and the SQL world of having a SQL solution that has ACID compliance, but it can scale out. So think of it as a very high performance OLTP solution in there. And I'm not going to talk more about this because I probably confused you enough, but this is a new category that we're seeing sprouting up, and there's a handful of vendors out there that are starting to get a lot of traction. So the various use cases, relational databases are going to be used for your OLTP, your in-house apps, ERP, CRM kind of thing in there. Your data warehouses you're going to build, those OLAP are going to be relational databases, still can be SQL Server, but you can go to an MPP solution, or like a Teradata or a Tease or APS, or you can use Hadoop. Some clients are using Hadoop as their de facto data warehouse. They generally still use that in combination with a relational database management system, because the factor is end user speed, and there's more complexity in having data in Hadoop and trying to make end users understand it. I mean, think about it, if you put it in there and there's no schema on there, well, that could be fine for a handful of power users who can figure it all out, but a lot of other users need a greater simplicity, and that's where a RDBMS may come into play, where maybe I'll first put data in Hadoop in a data lake, which I have on here, and then maybe I'll move some of that data into RDBMS, and that'll be used for other end users in there. And the non-relational databases, the NoSQL, will be used for those web and mobile, those global OLTP applications where I have thousands, if not millions, of users hitting the system. And then the relational and scalable OLTP that's where the NoSQL fits in. The CAP theorem, if we're familiar with SQL Server, we should know what this is. It's consistency, availability, and partitioning. And it's interesting because all the vendors, and that's where you got to be careful, will say they can sort of do all and be all to everything, but they generally have to sacrifice either consistency or availability in their solution because it's partitioned out. Now, our relational solution, we don't partition it out, and I'm not talking about the partition that you may be familiar with the SQL Server. I'm talking about partitioning by putting data across and sharding it across dozens of different solutions and automatically doing that, which the NoSQL solutions will do. So I like to think about it, if I want to maintain consistency and availability, I can't do both at the optimum level. If I want to do availability, say I have 2 nodes and one of those nodes go out, I can continue taking database requests in there, but if I have writes in there, then one of those nodes is going to be not consistent with the other one because it's down. At the other extreme, I can say if one node goes down, then don't take any requests. So, okay, I got consistency, but I have no availability. So all these solutions will fit somewhere in between the two, and they will generally sacrifice some response time depending on what they want to be. Since I work for Microsoft, I got to talk about just briefly all the solutions in here, and you can go back and look at this deck to get more, but a lot of people don't realize Microsoft has solutions for almost every of those categories. We have a NoSQL solution for document store and document DB. We have a Hadoop solution in HD Insights. We have table storage for a key value store. We have a MPP solutions on-prem and in the cloud. And now we're added JSON support to SQL Server 2016, so that kind of blurs the line, and maybe you can get away with using JSON in SQL Server if you don't have tons of users or rows in there. So it can work in some use cases, but just keep in mind it's not really scalable. So PolyBase is a great technology that can bridge the gap between some of these solutions. Now, if I have data in SQL Server and I also have data in, say, a Hadoop, I can use PolyBase to pull the data out of Hadoop and out of SQL Server and join it together using regular SQL. So if you're keeping up on some of the presentations, we had SQL Server 2016 introduce PolyBase. It's been in the APS and the SQL Data Warehouse for a while in there, but it's great to have sort of a federated query or a logical data warehouse approach to keeping data where it sits and not having to move it all into SQL Server. It's very easy and transparent to the users to use this. Essentially, I can do a create table statement, define the fields, and point to a file sitting in Hadoop, and from that point on, the end user has no idea it's sitting in Hadoop. They see it as a regular table. So they can do select statements off that and pull that data out. Yeah, you're not going to get the speed if it was sitting in SQL, but it's a great way to do maybe exploratory querying of data where you put it in a Hadoop solution and then you can PolyBase on top of that to pull it out and see if it's valuable. If not, if it's so, maybe you want to use it in your SQL Server. If not, you can just throw it away. When I was a DBA, the biggest pain is when someone says, oh, I got all this data, I want to use it, I write ETL, I move it into the SQL Server, and then they look at it and they go, well, I don't really need it. And now you wasted all this time. Or they created a report for one time. Now you just throw it all in Hadoop and then use PolyBase on top of it, and that end user can go and query that data and then see if it's valuable or not, or do that one-time report. If you talk about the data lake concept, which is other presentations of mine, but this is where PolyBase can really excel, because that Hadoop can be that data lake where you throw all the data in there and then use PolyBase to mine it all. I put this slide in here because Document DB supports various consistency options, and most of the other NoSQL solutions do too. So you can get ACID compliance by using strong consistency, but then you're going to sacrifice speed, and you kind of go against the whole purpose of using NoSQL. But it's there, and there's various layers here where you're sacrificing speed for more consistency. So keep that in mind, that these vendors will have various options for this. You have to talk about on-prem versus cloud in dealing with your solutions, because all of them will have on-prem solutions and most of them will have a cloud solution. The difference being they could either be infrastructure as a service or platform as a service. If I'm looking at infrastructure as a service, I could do a lift and shift. I could put SQL Server on a VM and have it out in the cloud, and the virtualization, the server, storage, network are all managed by Microsoft or other cloud provider. It's a great way to offload those duties to somebody else and not have that 2 a.m. call that something's wrong with the hardware. So we see in Microsoft a tremendous amount of people moving in the cloud, and all those solutions I talk about generally can work sort of as is on-prem in the cloud, just in a different VM. Taking it to another level is when you do platform as a service. or what's called database as a service, another fancy name for it. And products like SQL Database, SQL Data Warehouse by Microsoft, DocumentDB, and then Amazon has Redshift and RDS, where they also control the runtime and the middleware and the OS. So in infrastructure service, I have a VM, and I need to remote into that VM and control everything in there. Think of patching the SQL Server or the operating system. Platform as a service, I don't have to do that. All that's taken care of it for me. Think of it as behind the scenes, they are probably creating VMs and giving you memory and various performance metrics, but you don't have to worry about that. It's all taken care of automatically in there. So it really is the future. Everybody's going to move to the cloud. I tell people it's just a question of when. It may be 30 years for some, and you want to get to the platform as a service because it makes your job so much easier, and all that various maintenance and goes away, and then the high availability, disaster recovery, a lot of that's built into these solutions in there. So keep that in mind when you're looking at using one of these products if they have a cloud version, and if so, is that any different than what would the on-prem solution be? This is meant to scare you. There are so many solutions out there that can drive you batty. And this is from 451 Research put this up in here, and it kind of gives you an idea of where everything fits. So if you're looking at solutions, you can maybe focus in on one area and have some idea of the number of products. How they got all this done is pretty amazing in here. But they update it every few months, so definitely check it out for if you're looking at some categories of products you want to look at. I simplified it a bit and put it on this one to look at, well, we're looking at relational or non-relational, and then also separated out by operational or analytics, so we're looking like a data warehouse solution, and then where you're looking at proprietary or Hadoop storage in there. What's interesting in that Hadoop, where the monies get watered is I can have a solution like HBase that is a NoSQL solution, but it's actually built on Hadoop file system. So it's kind of a combo of the two. So is it a Hadoop solution? Well, it only has one of the Hadoop components. So it's more of a NoSQL solution, but you'll see various NoSQL solutions support different file systems. So Cassandra may support it also supports its own, but you can also run it on an HDFS and so on. So to make things more complex, they have different options for storage in there, and you just really, what it comes down to is you want to probably play with these on your use case, find out what's fastest, what fits and works best, and spend more time up front to make sure you're picking the right solution. Another slide that categorizes it, and it looked at the top 100 by DB rankings, which I'll say in a minute, but this was a slide that did a good job of putting them all in those various categories. Again, the idea is to help you narrow it down so you're not going crazy trying to look at dozens of products that really don't fit your use case at all. Sticking just to the Azure product categories, we have these various solutions that I mentioned before, and I try to put this in there to give you some better idea. And when we talk about the NoSQL solutions, when we look at analytical, that's where the Hadoop fits in there, and HD Insights, which is Horton works underneath the covers, and the great thing about that is it's the same thing. It's managed by Microsoft, so and it's quick to create. So I can have a solution in a matter of minutes. I can have a cluster of just about any size I want, and I can start developing right away with that. And at the same time, I can fire up other solutions in the cloud, such as SQL Data Warehouse and SQL DB. And in a matter of minutes, I can be playing with those too. So my takeaway from that is go and try them all out. Just go to your web portal and start playing around with these things. This is a great site that many of you probably know. DB Engines has this ranking of all the various systems out there. And it's interesting because the way it calculates how popular something is, because it can't go on how much sales, because some of these products are free. So it uses by dimensions on websites and the general interest and what it sees in social networks and things like this. And I found this pretty accurate. I'd like to say SQL Server is really #1 in my eyes, so maybe that's not quite as accurate, but it's all, of course, debatable in there. But you can see when we talk about Oracle and MySQL and SQL Server, they're far ahead of everybody else in there, the number of users that are talking about them and using them. MongoDB, the first NoSQL solution, the highest ranking one, is still well below the others. And you can see that while a lot of these products are talked about, they don't just have the impact that you would think they would based on what you read in the media. And here it is. If you look at all those categories and I put them in this graph, you'll see NoSQL only counts to 14% of it in there. So again, 86% are generally RDBMS solutions in there. So just keep that in mind, that it's sort of, have you ever seen the Gartner, they have this trough of expectations, and really NoSQL and Hadoop are at the very top, and then it starts going downhill where the reality sets in and people don't realize these solutions are not the be-all, end-all for anything, but rather have a purpose. You just got to figure out those use cases, which is what I'm trying to hopefully come across in this presentation. But that brings up polyglot persistence, which is a way to use the right tool for the right job. And by understanding all these various technologies, you can then use multiple technologies to build a solution. For example, if I'm building a web solution, I may want to use something like a key value store for shopping carts and session data, but for the completed orders, I may want to use a JSON document to have that. I may want to use a social graph, a graph store to have the relationships if I want to recommend products to them. If that's the kind of solution I'm building, I may want to use a graph store. And then I may want to use a SQL Server and such if to keep track of the inventory and the item prices and things like that. Now, you got to balance that. Well, I'm having more solutions, so that means I have to have more knowledge about all these products. So there's a trade-off in there. Generally, we have a hard enough time learning one product. Now we got to learn 3 or 4. James, you must be crazy. But I'm seeing this actually use polyglot persistence more than one technology all the time now. It's nearly impossible to build a solution that's going to be the end all to everything in there. So you're going to be forced to learn multiple technologies, and you're going to be better for it. So it's going to cost more time up front to build a solution, but in the end you'll have a solution that lasts a lot longer. And you're not having to go rebuild everything in a year or two because what you built wasn't able to keep up. Another slide meant to scare you. If I look at the modern data warehouse, taking what I just had in consideration, you need to add more complexities to it. So if we have DBAs out there, I'm sure we have situations where we create a database, and then we need to create a data warehouse, and we move it into there, and maybe we create a star schema, and maybe we're not getting the speed we need, so we create a SSAS cube, and then we have a combination of tabular and multidimensional, and then we have all the different front ends using it. Now we can throw into the mix, we may want to have data sitting out in a data lake, which could be in the cloud, and we can use PolyBase to combine that. And with SQL Server 2016, now we have StretchDB, and it goes on and on. So again, spend the time up front to learn these technologies, and you may want to implement many of them in order to avoid saying no to the end user. And that's what I hated as a DBA, when an end user would come to me and say, well, I want to put this data in here, and I have to say no because I don't have enough space, or we're having performance issues, or the SAN guys are complaining, or I'm bumping them against a maintenance window. I just can't fit any more in there. So instead, to avoid having to say no, think of the ability to build a solution where you take down all the barriers of requests that are going to come in from the end users. When we look at a hybrid where we put most of the technologies in the cloud, this is where we get into the data lake store concept. And I can throw everything in there as it is. I don't have to create any schema. I can have data that's either born in the cloud or it's coming from on-prem. And Microsoft has various solutions for that, like Azure Data Factory. We even have Azure Logic apps will make it really easy to take Twitter data and store it in the data lake. Now Microsoft has blob storage and a new thing called Data Lake Store, which is sort of like a super blob storage, which removes the limitations you have with blob storage, such as file size and account size in there. You can throw a 1 terabyte file into the Data Lake Store, and it also gives you a lot better performance in there. So that's just storage. Now we got to do something, some compute on top of that. So we have a lot of options now. We can use HD Insights, which is, again, Hortonworks, and I can use that to maybe filter the data that it's stored in the data lake store. I can clean it, I can master it. I can offload all those tasks. So instead of the data warehouse having to deal with them, now the Hadoop data lake is dealing with them. And then I can take subsets of that data and move them over into the data warehouse and build that star schema model out, as I mentioned before, and put it in an environment that's going to be much faster for the end user to create reports or dashboards with. I can use PolyBase, as I mentioned, to keep that data sitting there and pull data from the data warehouse and the data lake store. I can also use Azure ML right on the data lake store, or I can use them in the data warehouse. The great thing is we have drivers like Spark ODBC, Hive ODBC, so I can use a Power BI or Excel, and they can go right against the data warehouse, or they can go right against the data lake store by using Hadoop in there. And that makes it really flexible for certain users who can have the capability to go and pull that data that's sitting in sort of free form in a data lake store through Excel, while the other users who don't understand the data as well, they'll want to use a data warehouse and an easy-to-use tool like Power BI. And then we have this data catalog, which just went GA a few weeks ago, which is a great way to catalog all this data. It can find on its own. You can enter the data manually in there. You can comment and the data that it does find in there. You still have to invest the time up front to keep the data catalog up to date, but it really helps in building a solution like this, in that you're not having multiple copies of the same data. If you can train people to go look at the data catalog and see if the data already exists in there, you're not having to go and put that data in there multiple times. When I was a DBA, I can't tell you how many times I wind up finding the same data in tables over and over again because nobody kept track of it from a metadata solution. And up until recently, we had nothing from Microsoft, so I was really great when they came out with this data catalog about a year ago. And they've really made the product very easy to use and to find data. So definitely make that part of your solution when you're building out a data warehouse or a data platform. So you want to choose NoSQL. In some of these cases in there, it's new data, it's semi-structured, non-relational. You can get the training on there. You have done your homework and looked at the NoSQL products that fit for your particular case. You don't have to worry so much on the transactional consistency. You can sacrifice that for scalability performance when that's more important for your use case in there. And you need to service a huge amount of users, and at the same time you're okay with sacrificing some business rules by having that trade-off in there. So think about the relational databases are created for the strong consistency, but at the cost of speed and scale, where NoSQL sacrifices some of the consistency across the nodes to get the speed and scalability in there. But again, they're just technologies, NoSQL and Hadoop, for a subset of needs and use cases in there, so choose them wisely in there. But the lines are getting blurred. That's why I said do your homework. Almost every day, vendors are coming out with new improvements to their product, which is good in some cases, and it's bad in others. In my opinion, sometimes they try to be all to everybody, and then they get their focus off what they were really good at. And so you just keep that in mind when you're looking at these solutions in there. So here's the bottom line, what I say, if I got to summarize it all in a couple of sentences. Use an RDBMS like SQL Server for enterprise OLTP when you need the ASIN compliance, and generally any DBs under a terabyte of data, you don't need these other solutions. Your SQL Server is going to run fine. NoSQL is great for scaling OLTP solutions, in particular if you're using JSON documents, and a lot of products now, if you look at IoT devices, their output is in JSON documents in there. So using a NoSQL solution is going to be easier than trying to capture that information into a SQL Server. And then Hadoop for big data analytics, an OLAP, a data warehouse, massive amounts of data, huge queries, going to take a long time to run. Some of those you never get to run in SQL, you can get that in Hadoop. I talk a lot about this on my blog, so if you follow up with the slide deck, you can go and look into more of what I talked about in there in more detail. And feel free to shoot me an email if you have any questions on that. So with that, I gave myself some time so I can field some questions from the audience.
Yeah, we have a few questions, James. Let me start with the first one. How is the market share for NoSQL databases? It was mentioned at least 5 years back that NoSQL would slowly grab the share from RDBMS.
Yeah, it's one of those myths that's never going to come true. As the stats showed, it's 14% of clients are using it. And I always talk about, if you look at NoSQL and Hadoop, I always ask the audience, how many people know Hadoop? Everybody raises their hands. How many people are using the production? I may get 2 or 3 out of dozens, if not hundreds of people in there. The same thing with NoSQL. They don't know, people don't know it as much as Hadoop, but there's not a lot of people actually using it in there. When I go to clients, and these are general Fortune 500 clients, there are usually groups here and there that are using NoSQL, but it's for one-off projects. It's not for any other main systems in there. Where you see NoSQL used in the media companies, the big websites, the Googles, Yahoos, Amazon, those kind of things, they're big into NoSQL, but how many companies out there are at that level in there? And so you see all these great presentations by these big media companies, but they're just not relevant to a lot of use cases that I see in there. I see NoSQL actually a lot in startups in there because they don't have this experience. They're just out of college. They may not know SQL Server, so they're going to pick some technology to use, and they're just going to go with something like NoSQL in there, especially since it's free and you can start out right away with a solution and have to spend a lot of money up front. That's where we're seeing NoSQL. But in the general large enterprises, it's just not used that much.
Okay, the next one is, do you think the Azure Data Lake is similar kind of solution as Hadoop?
Oh yeah, a good question. So the data lake is the data lake store is just a storage, and it's blob storage. Now, I also see people, and you got to pair it with something like an HD Insights for the compute part of it. Alternatively, I can use Hadoop as the HDFS in Hadoop, which is similar in concepts to the data lake store, and the data lake store is also HDFS compliant. But if I don't want to use a Microsoft product, if I want to use a Cloudera or Hortonworks or MapR, I can fire up a VM and put the data in that solution in there. Now, the one trade-off you get, which Microsoft has a benefit of, is we separated out the compute from the storage. So if I were to put data in my Azure Data Lake store, and I can fire up an HD Insight cluster, and I can run some code to clean that data, and then I can shut down the HD Insights cluster. And I'm only paying for when it's running, so you're saving money that way. We also have an Azure Data Lake Analytics service, which is sort of a giant HD Insights cluster running all the time. So I can submit a job to that and use the data in the data lake store, and I don't have to fire up a HD Insights cluster. So it's another solution we have. Where the other products come into play, if you use one of their VMs and you put data on there, if you shut down the VM, then you lose the data in there. Now we also see a little bit in the market of some clients using NoSQL for a data lake. The caveat of that is most of them have to have JSON format, so I have to limit what I put in the data lake. I can't just throw a CSV file or a text file or a media file in there. I got to put it in the JSON format, so I got to convert it before I put it in the NoSQL solution.
This question from me, James. How to avoid data from data lake becoming a data landfill? Like, I mean, what are the precautions somebody can take? The Azure Data Lake remains a data lake, not become a landfill. Do you know what I'm saying?
Yeah, so I'm glad you asked that because I didn't touch on that. You don't want the data lake to become a data swamp. So all the data governance that goes on with building a solution like a data warehouse has to go on with the data lake in there. You can't just throw it in there and all of a sudden it's going to be this magic land of unicorns and fairies and data is just going to come out beautiful, which I just had a situation where somebody believed that last week. And you want to do things like have a area within your data lake store of where you put the raw data. Then you may want to clean it and you have another area where it's clean, and then maybe another area it's mastered, and maybe another area where it's good for production use for reporting purposes in there. But all that work that goes into building a data warehouse applies to a data lake. So you're not saving any time on building a solution that way. You can save it in other areas of scalability, of how quick you can fire something up, of the ability to scale out and not have to throw away data or say no to data in there. But you still have to have all those data governance procedures in place in there. And it's a big mistake clients do is they think there's shortcuts to that, and there's not. In fact, it could be even more work if you also got to move it into a data warehouse afterwards in there. Because the bottom line is the data is only going to be good as the person who understands it and cleans it and matches it in there. So you have to have those procedures in place. And so always keep that in mind when you're building a data lake out.
Yep. One more. Why do we say the schema-free for JSON and XML? Don't they have to be in a valid format to be recognized?
It depends which vendor you talk to. Now, some of them, they only have JSON formats or they have binary JSON. They have their own ways of storing the data. So they generally all have a certain way you've got to put it in there. And they all have various ways of converting the data. Well, okay, that's great, but that's another step you got to go through. And then there's various problems that can happen with converting the data or forgetting to convert it and things like that. So the NoSQL solutions all have to have it in their own format. Now, and then some of them support multiple formats and multiple storage solutions, so adding more complexity to it. And then, of course, Hadoop, you can store it in whatever you want. But the idea is they have to get that speed by having it in their own format. And the great thing is about something like a JSON document is everything you need is in there, but it makes it, and that's what makes it easier to scale, because I don't have to separate the data out. So I can say, well, I'm going to put the first 100,000 JSON documents on this server, and then the next 100,000 on this server, and on and on. You couldn't do that if you had to put it all in various tables in there, because you're going to have the ability, you have to have the ability to combine it all again, and you have to shuffle all this data around in there. So you avoid that with the JSON documents in there. So that's one of the reasons why they keep it in that, for scalability and also for speed.
Okay, and probably the last one, maybe, does Microsoft have a graph data solution?
Or you're going to end it with an answer where I'm going to say no. we don't have one. I've worked for Microsoft 2 years, and I've gotten to know a lot of people, and I have yet to find somebody who says that we are going to have one or it's in the works yet. So for now, we have plenty of third-party solutions. The great thing about Azure is we have all these pre-built VMs that you can go and choose from in the gallery. There's, I think, 750 of them. And there are various graph database solutions, as well as MongoDB and HBase are all on there. So even though we don't have one, you can go and quickly create a VM and have a graph database solution right away.
Okay, I think one more will do. How do we classify the mainframe storage?
Mainframe storage?
Yeah. I mean, probably the question means the relational, non-relational, or Hadoop, something like that, or big data, NoSQL.
Yeah, I'm not sure what they mean by that. I mean, if you have mainframe data and you want to use that, it'd be a source that you can put that data into a data lake and then consume it. And yeah, I still run into clients who have mainframes, and they're looking to take that data out of the mainframe and combine it with other data, which is a great use case for a data lake, because I'll take that mainframe data, I'll take Twitter data and data from some other on-prem sources and weather data and put it all in the data lake, and then perform some processing on that and maybe get value right there, and then maybe move some of those results into a SQL solution, and then create a star schema, and then run Power BI on top of that, and then open it up so this data can now be used by a wide range of end users because we've simplified it and we've created access points at various, reduced the complexity so various end users can get a hold of it.
Okay. I think we're at the end of our hour time. So probably the other questions which are not answered, we'll probably give it to James and he'll respond it to you on his blog.
Yeah,
before we go, thank you, James, for your presentation. Actually, I learned a lot. And probably the next coming up session is a SQL Server 2016 Hero Features in Action, full life cycle of financial data and SQL Server 2016 in memory and performance, in-memory performance. So, and please, I would appreciate everybody to, when they log off, to you fill out the evaluation form. That would be a great help. So thank you for attending and have a good evening. Bye.
Bye.